students, in last video already we have seen what the word logic means and the definition and the concept of some point, like what does it mean prepositional logic and what is preposition by itself or statement. And also we have seen logical operator. I think you remember there are 4 logical operators, and also we have seen a tautology and contradiction, and we have seen prepositional equivalence. And now let us continue our presentation. Chapter 1, topic 2. It says that open statement and quantifiers. First, let us see what does it mean open statement. By the way, open statement in nature, they are not a statement, but there are some sentences which may contain a variable and pronouns. For example, look, x is greater than 3. Students, can you say this is a statement or a preposition? Mean? Can we answer x is greater than 3 by saying true or false? Can you? Think about it. It is impossible to say this statement has a true value or a false truth value, because, for example, under set of real number, let us take 5 for instead of x. 5 is greater than 3. At this time, it will be true. And again, let us take 1. 1 is greater than 3. During this time, it is false. And in last video, we have seen when you define the statement mean or preposition is a declarative sentence which is either true or false value, but not both at a time. But this statement x greater than 3 gives, or it gives 2 answers under the given domain. So such kind of sentences are called open statements. By the way, students, why we say open? As the name indicated that such kind of sentence have a chance to be open. Where we can change to this open statement to be a statement. The chance is open, by the way. When we replace the exact value by the unknown variable or pronoun, we call it, and we will get a statement. For example, x is greater than 3. If you substitute one number instead of x, you will get either true or false value. At that time, it will be what? A statement. That is why such kind of sentences are open. Statement. Basically, they have 2 parts. These are subject and predict parts. For example, x is greater than 3. With the subject, x is the subject. The second one, or is greater than 3, is predict. Now, we can denote this statement by p of x. P of x. Additional example. Look, he is a doctor. Can you say this is a statement? Mean? Can you answer it either saying true or false? Impossible. Because, for example, he stands a person, I think, because it's pronoun. Now, let us take the universal domain, Ethiopian pupil. From that, take me. I know I am not a doctor, really. So, instead of he, Mutuku is a doctor. You will get false truth value. But let us substitute another person. For example, our Prime Minister. Abiy Ahmed is a doctor. It's true. So, open statement have a chance to be open. When you substitute an exact value or an exact person by the pronoun or by the variable. And the second one, x plus 4 is equal to 9. Now, it contains variable, so it is not a statement, but it is open. Means it has a chance to be a statement. But here, be reminded, not that all statements which contain variable may not be open preposition. Look, before we said open statement is a statement which contains variable, but here take care. For example, let us take x squared greater than 0. Now let us assume x is, or our universal set is, or our domain is a real number. I think you know what real number means. Or we will see detail in chapter 2 or chapter 3, I think. So, as you see x is variable, simply by observing x is variable, oh, this is open statement. Can you say? Impossible. Because it depends on the property of the given sentence and the given domain. Now, from the set of real number, take one number and square it. Can you find the square of any number which is less than 0? We can't find. Take any number, square it. When I say any number, you will take from your domain. Your domain is set of real number. So, take any number, square it. It is always greater than 0. Sure. Take 5. 5 squared is greater than 0. 25. Minus 5. Like that. But here, take 0. 0 squared. 0 squared is greater than 0. So, you have to correct this example to be a statement. X squared greater than 0 is still it is open statement. But if you add greater or equal, at that time that is not open statement. By nature it is what? A statement. So don't forget that there are some statement which contains variable which contains a variable, and they are statements. And last, my explanation. Open statement have a chance to be a statement. The method is, or the way is, using quantifiers. By the way, quantifier is a group of or a collection of number or persons. Quantifiers is nothing, it's simply a collection or a group of person or numbers. there are two types of quantifiers, by the way: universal quantifier and existential quantifier. Existential quantifier. Let us in detail. By the way, the universal quantifier have the symbol like this. The reverse of A, I think. And the existential quantifier, A reverse. The mirror image, I think. Is that the mirror image? No, it is not a mirror image. Or, yeah, A maybe, yeah. It's the symbol, don't matter. Don't worry about this. So, but what does it mean? For all x, p of x means, we can read, for all x satisfies the property of x, p of x, or for each x satisfy property of p of x, or for every x satisfy property of p of x under the given domain. Under the given domain. The existential quantifier of p of x is the statement. It means that there exists an element x in the domain such that p of x, or when we read it like this, there exists p of x, means there is an x such that which satisfies property of p of x, or the given statement, or from those given domain there is at least one x such that satisfies p of x, or from those numbers or persons, it's based on the given domain, which satisfies, for there are some x's. X may be number or persons which satisfy the p of x. So, for a universal quantifier, in order to get a true value, every x must be satisfy the given statement. But if there is at least one x do not satisfy p of x, that statement will be false value. But when it comes to the existential quantifier, true value, there is an x for which p of x is true. An x, I said, and means single x, a single x, or some x, it is false for every x, Now let us see example. As I said before, look this, x less than 2. This is open statement because it may be true or false. Now, look, what does it mean? All x, q of x mean? First, you have to identify your domain. Okay, our domain is a set of real number. Okay, so when you read it, all real number satisfy q of x. What is the property of q of x? Is x greater than 2. So it means that all real number is less than 2. As the time it will be very easy. Is all real number is less than 2, my student? No, at least if you have one answer to be false, this statement will be false. So x less than 2, for example 1 is a real number. So now first let me read it. All x satisfy q of x, then all real number less than 2. Now it is what? A statement. Before it was what? Open statement. So, all real number less than 2. Automatically it's false. It cannot be true. At a time it has one answer that is false. So, this is a statement. The mechanism changing open statement to be open statement is simply using quantifier. Simply using quantifier. So it is false. But instead of this, for all x q of x, if it was there exists q of x, means there exists at least one real number which satisfies q of x, means there exists at least one number which is less than 2. Yes, of course, we can mention it. For example, 0. So it is true. So the truth value is true. So these quantifiers help us to change open statement to a statement. Let us add examples. Look this. Q of x, x squared greater than 0. So let me ask you, what is the truth value of all x? For all x, q of x means that. Okay, bear in mind here, your domain is integer. Your domain is integer. Integer means what? The positive counting and the negative counting, number including 0. Integers. So, all integer, the square of all integer is greater than 0. Are you sure? For example, take minus 1. Yes. 1 greater than 0. 5 greater, 25. Can you take 1 over 2? Impossible, because your domain is integer and 1 over 2 is not integer. And negative 5 squared, 25. Yes. Can you find the square of integer which is less than or equal to 0? Yes, of course, 0. During universal quantifier, if you get one number which not satisfies the given statement, that at the end of the day, the given preposition or statement have false value. Now test from those integers. 0 squared is not greater than 0. So q of x has a false truth value. A false truth value. What about instead of for all x, there exists an integer q of x. This is I left this to answer it. Okay, there are some additional examples, so look and understand it. I think already I said this, q of x, x greater than 3. What is the truth value of this? And the domain is a real number. If you get one numbers to be true, then automatically that statement will be true. For example, let us take 4 from real numbers. 4 greater than 3. Enough. So when using existential quantifier, when you get a false value, if there is no element in the domain for which q of x is true, Now look, under set of real number, x is equal to x plus 1. Can you find any number which satisfies the property of q of x. Q of x means k. Can you find? By the way, a set of real number is very infinitely. So, can you find from those infinite numbers at least one number which satisfies this? Impossible. At this time, this statement will be false, false, false. So, in this topic, already we have discussed about what is open statement and what is a quantifier and the relation between quantifiers and open statement. Here, I left to you for further understanding about topic 2 is activity 1.2. So please do it, and if you have any doubts, questions, put your question in my email. I will left my email at the end of this chapter. Thank you for watching this topic 2. And next we will continue topic 3 and topic 4. Thank you very much. See you.